What is SQL? So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze and manipulate databases.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases.
Happy learning.
In this video, we will learn everything to master structured query language or SQL. This full course video will help you write SQL commands using MySQL, PostgreSQL, as well as SQL Server. Our highly experienced trainers will take you through this course. So we will start by learning the basics of SQL along with understanding entity relationship diagrams. Then you will learn how to install MySQL Workbench on Windows. We'll look at the popular SQL commands to select, insert, update, and delete records and perform other operations on database tables. You will see how to use the top numerical and text functions in SQL. Next, we will cover how to use group by and having in SQL followed by joins. So you will learn the different types of join statements as well as subqueries in SQL. Moving further, we will understand triggers, stored procedures, and window functions in MySQL. You will get an idea about another important topic, that is to write SQL queries with Python on Jupyter Notebook. Then we will look at another free and open source relational database management system, that is PostgreSQL, with extensive hands-on demonstration. Finally, you will learn how to become a SQL developer and see the top SQL interview questions that are frequently asked in the interviews. So let's get started with what is SQL. In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access. In this session, we will learn about ER diagram, starting with what is an ER diagram and why it's been so much used by the companies. Then we will learn about the symbols used in the ER diagram and get familiar with the components of it. So hey everyone, I'm Abhisar Ahuja from Simplilearn and welcome to this video on ER diagram in DBMS. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. Let's start. Have you ever wondered how these big e-commerce companies manage their tons of data that keeps updating every second? And these data sets keep on updating in their databases. To perform operations on this data, they should have a conceptual understanding of these databases. And this is done by understanding ER diagrams of the databases. So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and their relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we'll move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission, click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL server, MySQL shell, and the MySQL workbench. Expand MySQL servers by double-clicking on it and choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we'll go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on finish. Now the shell and workbench has started. Now we will connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL 80 and enter the password to connect to the local host. The MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns underscore prive, component, DB and much more.
Let me now go ahead and open my MySQL workbench. So in the search bar, I'll search for MySQL workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL workbench. And below under connections, you can see I have already created a connection which says local instance. Then you have the root, the local host and the port number. Let me click on it.